So we'll move over here a little bit. And now, AC isolator. I see an isolator, I go, and there's no fault current protection. It turns off when required. But this is a misnomer because it's
a multi-use. It is an isolator as well as a circuit breaker. Because we've got the buzz duct directly behind it, these 90mm cables do not have any circuit protection. So to provide the circuit protection as well as a point of isolation, we've actually got these boxes fit out with a circuit breaker that is being used as an isolator also.
Right, so we're talking about a, what's the rating on these?
These are 200 amp.
200 amp, and I noticed if we close it, we've got 200 but 170, so we have to redo that.
Yeah,
that was a mistake by the printer.
This was a labelling mistake.
Yeah.
They're all going to be replaced with a 200 amp.
And I know what we tend to do on the grid safe interface protection boards is most of the time we use a 250 amp Schneider, and it's dialed down. I won't say it's derated because it's not. It's actually physically dialed down. This breaker here is it looks like it's an Eaton. And now, so I'm going to ask a question, Alex. If you didn't, on a system like this, can you put the circuit breakers in there without having any kind of isolation here?
You could, because of the new standards, the 477.1. They've actually changed that so that as long as the first inverter of an array or bank of inverters is within 3 meters of your isolation switch, direct line of sight, that the rest of the inverters don't actually need it to be isolated, have an isolator adjacent.
Yes, yeah, that's what I thought. But I sort of like the idea that they've got their dedicated enclosures and then you don't have to actually open up.
I do like this idea also.
Yeah.
It makes it quite obvious if you come out to service or maintain the system.
That's the thing.
You know where to go.
And on a bigger site like this, yeah, it might be a little bit more costly, but it's more practical and it's easy to access, and I think that's really, really important. So now the actual skid is 2 pieces, and you can notice here. Yes, we're going to show boots, warts and all. This is really dirty. So what's happened at some stage, and we're not sure who it is because it wasn't us. One of the contractors has been on site, has been walking all over it and left all that dirt and the whole stuff, and that has to be cleaned up. What I want you to notice is that this skid is in 2 pieces. The primary part is the transformer because it weighs so much.
Yes, this is the transformer and main switchboard side of the skid.
And you can see here it's stopped there, and then this part is the inverter station skid, and we've got some earthing to connect, keep the continuity going. So that little bit of heat shrink on there, is that a requirement for them, or is it just?
That is just good practice.
That's what I thought.
It's an indication of the use of that bar.
It really looks good.
Yeah.
So, and you can see inside. We'll go to there. You can see inside the circuit breaker there. You've got the 95mm at the bottom. You got your glands. You got your mechanical protection. It's all very, very neat. Now, we're almost at the end, but I'd like to draw your attention to the inverter station. And Alex, would you like to talk a little bit about the inverter station, as in the roof, the frame, and why it's there? Because we know that these inverters have got a pretty good IP rating. They can go outside, they can go.
Yes, even though they have an IP rating to be out in the weather, it is best practice to cover the inverters, because if they get hot from direct sunlight, they will derate themselves. So for best production out of the system, we have a roof which will not only keep the system cleaner, keeps the water off it, it does actually make the system produce better. And
that's the thing. So people would see who wouldn't realise that they go, oh, there's a roof over it. It's because, we don't want to get water and what have you on it. No, it's nothing. These can be, you can spray a hose at these things. It's more about maintaining maximum production from the lovely energy that they receive from the panels, and maximising that production, because
not only production, but also expand the lifetime of the system. If components inside get too hot, they wear out. Because in electronics and electricity, things like to be cold, don't they? They like to be cool, you know. And it's a funny one with solar, isn't it? When you think about people go, oh, really hot day, panels are producing magnificently. That's just not the case. Well,
on a cold, clear day at 20 degrees or less with the sun pump, they're pumping out.
That's really exactly right. Out. Nice, clear spring day is the best day.
Have you ever seen panels produce like right almost at their short circuit current? Like in your...
Doing short circuit testing, I have, yes.
Yeah, wow.
So while you're doing a short circuit test on an array, there is potential to see that, especially if you're doing it quite early morning on a cold day, like you're saying.
Yeah, wow.
And the sun is clear blue skies.
Yeah.
Yeah.
I mean, that's really interesting, isn't it? Now, we haven't talked much about the voltage of the string. So there's 18 panels, and I did a quick VOC max calc, and it would go over the capacity of these. If you put 20 in the string and 18 was the number, but you're talking up around 850, 900 volts, aren't you?
Yeah, so when we tested these strings, most of these strings are about 930.
Wow.
When I was tested.
And that's voltage at maximum power point?
That's VOC, not
maximum. Oh, that's VOC, yeah.
So at maximum power point, be slightly less. Probably bring you right into your optimum range for this unit.
And the VOC max, obviously, we're talking about the VOC of panels off the data sheet, but the VOC max takes into consideration the coldest temperatures that a site like this would experience. The general rule of thumb most people use is -10. If they're getting close to that max, they might buffer it down to -5. But I'll tell you what, out at Wendouree, Ballarat area, you'd be leaving it at -10.
Gets pretty cold out here.
Because it gets pretty cold out.
It's pretty chilly.
So you can see on this side here, we have the 5 inverters. The actual inverter station has been constructed out of a frame, a hot dip galvanized frame. They've used a uni-strut framing as well that interfaces between the inverters and the custom-made frame. That's bolted to the actual skid, the inverter skid. And notice these points here, obviously this is from a crane perspective. So, and they crane this into position. And you might be able to hear a bit of a noise because, hey, they're pumping. This system is on.
We do have a bit of clear sky at the moment, hitting the panels.
It's pretty good, yeah. And that obviously shutdown procedure on each of the inverters. And we come back to the right to the front. What's one of the best things about working on a ground mount system?
One of the best things about working on the ground mount system is uniformity. When you're working on a rooftop solar system, you get a lot of obstacles in the way. You get uneven string numbers due to that fact, and it can create a bit of confusion when you get to the inverter side to wire it all back into it. Whereas with this system, as we have the tables which are ground mounted, you have every single string is exactly the same length. You have exactly the same amount of panels on all throughout site, and there's no confusion.
Yeah, look, I think that's a really good point. And I think also too, from a work perspective, for the people actually doing the hot work, you're on the ground and you don't have that tension in your body from a roof mount. But I love ground mount. I really like walking around. I love that concept that you're obviously producing energy from the sun. Ground mount's interesting. Agrivoltaic ground mount even better. But that's our next project. I really want to thank you so much for your time. I know how busy you are. I appreciate that. So thanks, man. Cheers.
Thank you.